Welcome back everyone. So in this video we will be looking at a few examples of calculation regarding molarity. So as you can see in this slide, I already put the triangle of molarity there and a table for solute, solvent and solution that hopefully will help us in solving this question. So let's take a look at example 11. Determine the molarity of solution. So you were asked to calculate the molarity of solution of sucrose, okay, when 1.71 gram of C12H22O11 dissolved in 0.5 liter of water. The first thing that we need to do is to determine, okay, which information indicates solute, solvent or solution from the question. So from the question, the solute is sucrose, and we can see that sucrose is dissolved in 0.5 liter of water. So meaning to say the solvent would be water in this question. Therefore, when sucrose is dissolved in water, the solution that we will get is sucrose solution ataupun solution of sucrose. After we determine which one is solute, solvent and solution, then we can fill in the information given from the question into the table. The question asks us to find the molarity of the solution. So molarity is equal to number of mole of solute divided by volume of solution. So how can we find the number of mole of solute? So the information given from the question is the mass of the solute. So from the mass of the solute, actually, we can find the number of mole of the solute by using the formula mass divided by molar mass. So what we will do, we just substitute all the value inside the formula, and then we can find the number of mole of solute is equals to 5 times 10 to the power of -3 mole. Next, we have to determine the volume of the solution. But as you can see, volume of solution is not given from the question. But we know that the volume of the solvent is 0.5 liter. So actually it is like this, okay? We have water 0.5 liter and the solute, which is the sucrose in solid form, is added into the solvent. So because the solute is in solid form, meaning to say the volume of solution will take up the volume of solvent. Therefore, the volume of solution will be 0.5 liter. So to find the molarity of solution, it is equals to the number of mole of solute divided by the volume of solution. So we just substitute the value that we calculated before and substitute the volume of solution to the formula. And when we calculate, we find that the molarity of solution is 0.01 molar. Next, for example 12, okay, the question asks us to find how many grams. So how many grams, this indicates the mass, okay. The question asks us to find the mass of potassium dichromate required to prepare 250 ml of 2.16 molar potassium dichromate solution. Okay, so the first thing we need to do is to fill in the table of solute, solvent and solution. So the solute is K2Cr2O7. The question did not indicate any solvent that is used, and then the solution is potassium dichromate solution. So from the question we can determine that The question asks us to find the mass of solute, and given, okay, the volume of solution is 250 ml and the molarity of solution is 2.16 molar. So how can we find the mass of the solute? So remember, in the previous class we already learned about this triangle. Okay, so to find the mass of the solute, we need to have the value of number of mole. So how can we find the number of mole? So as we can see from the triangle above there, the number of mole of solute can be found if we have the value of molarity and also the value of volume of solution. And these two is provided in the question. So what we have to do is just substitute the value inside the equation, okay? And then we have the number of mole of solute is 0.54 mole. And then after that, we need to find the mass of the solute, in which the mass of the solute is equals to the number of mole of solute times with the molar mass. So what you have to do is just substitute the number of mole of solute that we calculate earlier times to the molar mass of K2Cr2 of 7, and then we will have the mass of solute is 158.868 gram.